Thank you. Good morning, and thank you for being here again. This first session have three speakers, Susan Blackmore, Dave Chalmers, and Robert Clowes. And in this order, the first talk is called, What is it like to be artificial intelligence? The same topic of the conference. And every speaker has 30 minutes, half an hour, and 10 minutes for discussion. The floor is yours. Thank you.
Well, what is it like to be artificially intelligent? Well, we don't know, do we? And I don't know what we're bothering about. But I'm going to start by saying that I think the whole field of consciousness studies has got itself in a mess. I'm secondly going to say I have the most brilliant, amazing idea to get out of the mess. Well, we'll see. And thirdly, I'm going to apply this idea to the question of what is it like to be artificially intelligent. So we've got it all wrong, but we have no definition of consciousness. Now, we got on kind of fine in a way without a definition of consciousness, but it's a bit weird, isn't it, to have a subject that there's a whole field of consciousness studies and we haven't defined what it is we're studying. Okay, so what did we do instead? Oh, God. But we do have a lot of theories. Lots and lots of theories. I've just got a few examples here. Mudrik et al. Have 5 theories to compare. And Fahadi has 7 theories to compare. And Seth and Bain recently clocked up 22 theories. But that's nothing. Today, the landscape of consciousness, I only heard too late to put it in my presentation. Literally, just the email came. It's gone live, Landscape of Consciousness. And in that great paper is 500-page paper, whatever it was, of Landscape of Consciousness. He had 225 theories, and now on the website are 275. Now, there's surely something a bit weird about a field of study that has so many theories. Now, it's great, as I'm sure you know, there's been started to be collaborations, adversarial collaborations to try to test different theories, notably global workspace theory against IIT. I was not surprised that the results did not come out saying one or the other is right. It's great to try and test the theories, but hey, if you've got 275 of them, it's going to take a while. So, where did we go wrong? I blame the bat. Poor bat, it's not really the bat's fault. And it's kind of not Nagel's fault either. So, as you know, in 1974, Nagel asked that famous question, what is it like to be a bat? There's good and bad about that. The good, in my opinion, the good is it focused our attention on what it's like to be, because that's kind of the problem, isn't it? I mean, what's it like being you now? Just have a moment. That's what we're trying to explain. So by asking what it's like to be a bat, he's taking an animal with different senses and so on to make it difficult, but the point is there. And that's what we should, I agree, be focusing on. But hang on a minute. He talked about the bat. The bat is a physical object. And as soon as you say that the bat is conscious, or any physical object is consciousness, a robot or a human being or an ant or anything you like to choose, you've got the hard problem. You've got the explanatory gap. You've got on one side subjective, what it feels like, so on the other, what we take to be a physical world full of physical objects. So you're inevitably got the hard problem. Now, lots and lots of people have said the hard problem is the wrong problem, a non-problem, or I like Pat Churchland's best, the hornswoggle problem. I don't know what a hornswoggle is. Anyone know what a hornswoggle is? Anyway, I like the sound of a hornswoggle problem. And I agree. No. Sorry, I'm going mad with this thing. Now, this is taken for granted And I bet most of you, perhaps not all, take this for granted, that the question we're asking is about how can a physical object give rise to consciousness or be conscious or whatever it is. Now, this, some people think this is undeniable. It is undeniable that some organisms are subjects of experience. Fine, but not fine, in my opinion. This is what I'm going to deny. I'm going to reject the idea that a physical object can be the subject of consciousness. Nagel makes the same assumption. The fact that an organism has conscious experience at all means, basically, that there is something it is like to be that organism. Now, we've taken this for granted, the whole 30 years or so. I mean, consciousness studies really began 1994, and Dave Chalmers kicked it off with creating the hard problem. You've got us stuck in this, Dave. No, I think you've made it a lot better. Thank you for the hard problem. But it's been that long, 30 years, and here we are today in this mess. So my claim is that there is nothing it is like to be a bat. Not because there's something it's like to be a human being, but because physical objects, in my opinion, cannot be conscious. I'm going to replace this with the idea that it is the predictive models of a Bayesian brain that are the subject of consciousness. I expect most of you know what I mean by Bayesian brain, but in case any don't, let me just give the gist. I think that predictive processing theory is really kind of rushing through neuroscience and having a big effect, and it seems to me to help us enormously. So the basic idea of the Bayesian brain is that rather than information like kind of seems intuitively, information's coming in the eyes and the ears and nose and everywhere, and it's going up through the processing up to the top where, da-dam, I'm conscious. It's the opposite. We are actively inferring the causes of the inputs that we're getting. So the Bayesian brain, what it's basically doing, a massive hierarchical system in which at each layer, or each level of this hierarchy, what the neurons are trying to do is to predict what's coming in from the next level below. Now, to do that, they have to make some kind of prediction using their priors, or the prior information that they have, make a prediction about what's coming next. And the better their prediction, the better the organism gets on. But all it's doing is checking, and when there are errors, error messages go up the system. So what we have is something we've known since probably 100 years, since the first staining of cells in the brain and so on, is that there are more neurons going outwards towards sensors than coming in. And this seemed kind of a puzzle, but it makes sense now. So it's a top-down process. This is why people talk, like Anil Seth and so on, and Andy and many others talk about controlled hallucination. So we are hallucinating a world, in other words, predicting trying to understand the causes of our input, and that's controlled by the input. So this is the kind of idea I'm working on. And it seems to me, well, look around you now. How are you seeing? You are seeing by actively inferring what's out there. This experience now is the model, the top model, the most obvious model in the brain. Now, by saying this, let me just leave that there a minute. By saying this, please understand, I am saying that there is something it is like to be the models that your brain is building. And I don't just mean the big model with a great big self at the top. So down at the bottom of the hierarchy are the sensory inputs, V1 and whatever, LGN or wherever you want to start. Very simple models. Lines, edges, squares, then object recognition. All of these are models at different levels. And way up there in the top of the hierarchy is this big me, da-dam, I'm really important, I'm here, I'm sitting in the room, I'm looking out at you, this mouth is talking, blah, blah, blah. And that's what we take to be conscious. I'm making this possibly mad claim, that there is something it is like to be all those models at every level. That's what they are. How can I mean this? Well, here's the point. If you ask what it is like to be a bat, you can't answer. We've tried and tried. But if you ask what is it like to be the bat's model of a bat, or the bat's model of what it's doing, or the bat's model of the world it's flying through, or the other bats around that it's avoiding, or the insects it's catching, well, what is it like? It's like whatever the model says. So if you have colour vision and the model's, it's saying it's green, not red, whatever, if it's a complex model somewhere in your brain that's detecting chairs and moving your feet in the right place and whatever it is, it's describing. These models are describing worlds. And for us, they're describing selves in worlds. So this is why I say, if we ask what it's like to be the bat's model of the world, we can answer. We say it's like whatever the model is describing. And that's all there is. We don't know what's out there. We can't ever find out except through models. I'm not going to get into the metaphysics of that. Sorry, I'll only get so far with this argument. So I want to note something important here. Sorry, I keep getting this wrong. When Dave formulated the hard problem, he described it in different ways, but this is one of the ways. And it's a question of how physical processes in the brain give rise to subjective experience. And he contrasted this, as you know, with the easy problems, and asked, why is the performance of these functions accompanied by experience? So I want to emphasize two things there, which have been taken to be so obvious and constantly referred to in the consciousness literature, that the brain gives rise, or that neural processes give rise to consciousness. It's something else that kind of isn't there, and then it's given rise to, and it is there. And it's accompanied, the functions of seeing and hearing and thinking and speaking and all of these are accompanied. So this leads you into a kind of dualism, and as you know, Dave does end up with a kind of dualist view, a very subtle one, not a Cartesian soul-type view, but dualism nonetheless, which I think is inevitable if you take this view. Now, if Dan were here, he'd say, yeah, they're all Cartesian materialists. What his point about Cartesian materialism was that so many neuroscientists and psychologists and so on say, well, I don't believe in Descartes, I'm not a dualist, but then they think about themselves as an audience in the Cartesian theatre and so on. And that's still happening. I would say the vast majority, I write CM in the side of every paper and every book that I read, and it's all over the place. Oh, you're a Cartesian materialist. Of course, they might be right, but I don't think so. Now, so just to sum up, I am claiming that all the models created in predictive processing brains, there is something it's like to be them. Now, does anyone agree with me? I'm not going to read out these, and you don't have to read them either. I'll just summarize. Anil Seth says that conscious contents are not merely shaped by perceptual predictions, they are these predictions. In other words, predictive processing predictions. But he talks about conscious contents as though consciousness is a container. I wrote a paper 20 years ago saying that consciousness isn't a container, but he may not mean that implication, so I don't know. So he's pretty close. Michael Graziano, I wrote to him recently because I wanted to know what he was thinking. And I said, I think people go wrong when they say bats or fish or people are or are not conscious, and that some processes in the brain are or are not conscious. And he said, I 100% agree. I've been saying it for a long time. The question itself is conscious is ill-posed. But I don't think he goes the kind of last step to say all predictive processing models are conscious. But I have not met him to talk about it, and this was just email. And then Keith Frankish, with whom I've had lots and lots of, he's been really helpful in helping me with the paper I'm trying to write on this. And we're trying to thrash out where we agree and disagree. But I wrote, I am completely rejecting the idea that physical objects can be conscious, and along with it, the idea that brains give rise to or generate consciousness. So he disagrees with the first one, but he really loves the second. So I think those are the best that I can find from there. This is Andy. Human experience arises at the meeting point of predictions and sensory evidence. But it's still arising. And I'd like to talk about that, Andy, because there's all sorts of things you might mean. It might be bad arising, and it might be some other kind of arising. It's tricky not to use that word, so let's see if we can get anywhere with that. And Seth and Bain say the distinction between conscious and unconscious states is part of the best guess. But they're talking about the distinction between conscious and unconscious states. And I'm saying that all of the states, all of the processes, all of the models, there's something it's like to be them, because that's what a model is. Sorry, I keep repeating it. But I know from a little bit of experience, because I've only been talking about this for a fairly short time, that people don't get it. Now, if you don't get it, fine. You might be right to not get it because it's rubbish. If you do get it, great, because then you can help me decide whether it's rubbish or not. So that's why I'm kind of labouring it a bit, because I need help. And then Howie, who's a great proponent of predictive processing theory, says what gets selected for conscious perception is the best, best model at the moment, gets selected for conscious. So everything else is unconscious and some things get selected. And the only person that's disappeared off the bottom, the only person who really seems to agree with this is Shamil Chandaria, who's not written anything about it. He's got some brilliant lectures online, talking from a meditational point of view largely about taking the top layers off, letting go of the self model, then the others become more obvious, and so on. And we experience models bearing in mind that we ourselves are one of those models. We are a self model. We're way up in the top of this hierarchy, a great model of self that thinks the audience in the Cartesian theatre, it feels like that I'm in here, I'm in control, I've got free will, I have consciousness, and all that. So, something strange. Right, so now and how long have I got? 10 minutes. Oh, good. Right. So this is the second section really, to think about the implications for neuroscience. Now, I do not think that this is a theory of consciousness that can be tested against the other 274 theories in that big list. But I think the implications for neuroscience of consciousness are that we would go about it in a completely different way, and we would abandon a whole lot of the things that we've been doing and are still doing. And people are still doing, I'm not doing them. Now, let's start with the question. I've done this lots of times with students and in many lectures, and I'm going to make you do it really, really fast, just for fun, and I want you to put your hands up very, high up in the air so that everyone can see what's happening. So which of these is conscious? Who thinks the stone's conscious? Hands up if you do, quick. No panpsychist at all? Da-da! Who thinks the thermostat's conscious? Dave a little bit. You're being very dodgy, all of you. Maybe you haven't got hands. Who thinks plants are conscious? Oh, we've got quite a lot now, maybe 20%, whatever. What about insects? Oh, lots and lots. We're well over half now. What about a cute little furry rabbit with little ears? Oh, yes, nearly everybody. And what about that horrible screaming baby? Okay, hands down. Anyone not think anyone? Hands up if you don't think the baby's conscious. Oh, quite a few. Okay, how are we going to find out? Well, we can't, and we've known this ever since the beginning of the whole subject. We can't find out. People can go on arguing forever, and they do incredibly complicated and serious work to try to find out. So I would say that instead of asking which of these is conscious, we should be asking what models of self and the world are these things building. Then in principle, it may not be easy, but in principle, you can find out. I mean, a stone isn't building any models. The models built by the thermostat are fleeting and momentary as it switches from one to the other, and so on. But people could try. So Bain and colleagues recently in TICS made a list of lots and lots of ways of trying to detect consciousness. Now, they said that they were not looking for the side effects or the correlations. They wanted to get at consciousness itself. But actually what they've done is all these kinds of tests. The sniff test, well, the thermostat can't do that. I'm not sure about the rabbit could. Perturbational complexity index and so on. And they drew up a whole table of things that passed the test and didn't pass the test. This is what happens. I mean, it may lead somewhere. I may be completely wrong, and I'm willing to be, but it seems to me that this is not ever going to get us the answers that we want to understand what it means for us to be conscious. So I keep saying don't ask. So don't ask what is the function of consciousness or why did consciousness evolve. Now, Nick famously long ago, and I love this thought, said either we have to throw away the idea that consciousness evolved by natural selection or we have to find a function for it. And that kind of seems obvious, but I think it's wrong. Because it doesn't have a function. Because if it is what it is like to be a model, the models have the function. The models are doing the work. That's the entire work, what the brain is doing. And that's what evolved. The ability to be a really good predictive processing brain, that's what had selection pressures operating on it and had advantages that meant we got it. And that's why we are what we say we are conscious. So I've struggled with that, Nick, as you probably know in my textbook. If anyone wants to look at the textbook, I've put a copy out there. And the fourth edition that came out last year. It was published on the 19th of April, the day that Dan died. I was on my way to launch the book at the Tucson conference and heard on the journey that he had died that day. Well, if I believed in heaven, I hope he'd be sitting up there and he'd like the way the universe unfolds. So we shouldn't be asking what the function is. And there are lots and lots of people coming up with functions. And I think they're not going to find them. And we shouldn't ask how or where does consciousness arise or is generated, because it isn't. I mean, at least what I'm trying to say is it's not generated in the sense that you can have an unconscious process that then becomes conscious. So global workspace theory, at least in its original Bars version, and to some, yeah, I think probably in the neural version as well, but things become conscious when they get into the global workspace. Now, Dan interprets that in multiple drafts as the broadcast and so on, which is slightly different, but basically it's saying that you have unconscious processes and conscious processes in the brain, and unconscious ones can become conscious or they can get into consciousness. And I am denying that because I'm saying all of the models are already, there's something it's like to be all of them, so it doesn't make any sense to ask which ones are conscious and how they come to be conscious or how they're generated or how they arise. All of this is barking up the wrong tree. And finally, don't ask, I don't know why these moved wrong from when they were on my laptop, but never mind, you can read them. Don't ask which processes or contents, items, perception, etc. are conscious and which are not. Now, I said things get into the global workspace. It always amuses me when I read stuff about it because what actually is it? Sometimes people say information, sometimes they say items, sometimes they say things. Bars himself varies in what he originally said, gets in there. And that's kind of another little indication that we've got a problem. Anyway, this is a bit upsetting to, I think I missed out that bit. This is a bit upsetting to the great hunt for the, 5 minutes to, yeah, the great hunt for the neural correlates of consciousness, because that's what so many people are doing. And I'm saying there's no such thing as the neural correlates of consciousness if you interpret consciousness as something that can come or go, be added to things, or is in addition to, or is generated by, or arises from. And so you don't ask which are conscious and which are not, because there's something it's like to be all of the models. But why then, here's a problem, does it seem as if some things in our minds are conscious and some are not? And we talk about I'm conscious of this, but I had this unconscious experience and subliminal perception and blah, 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 blah. I am replacing the whole idea of things being conscious or not conscious with the idea that they are part of the self model or they are not part of the self model. So there is this massive, huge model that's for all of you now. You may be wandering off and unmindfully, but if I, hang on a minute. Are you conscious now? Oh, I love that. A few people go, ooh. Now, some of you would have had the wonderful experience that you realized that a moment ago, well, you were listening and you were sat there and breathing, but you weren't actually kind of here. And then you become mindful or you become present or something when I asked a question. I like to catch people out, I like to catch people catch me out, and then I'm going, oh, God, I've gone off into a dream again. Anyway, my point is I'm replacing the idea that processes can be conscious or unconscious with that conscious or unconscious to me. They're either part of the self model or not, and they come in and out. So when I asked you that question, suddenly the self model becomes higher precision weighting on it, more attention. It becomes bigger and more, it has more stuff in it, and then we get this feeling that it's become conscious. Now I'm conscious of it. And that is how the illusion is generated. The illusion that's kept us in thrall all this time, that consciousness is something that's generated by some brain processes and not others. So finally, I don't know much about AI, but I know an awful lot more than I did 2 days ago. So thank you to all of you, and I'll learn a lot more today, no doubt. So I'll just throw in a few ideas about this. If you start, and I want to just think of these three important things. If you think about the nature of the models that artificial systems build, and to what extent they are anything like what our minds seem to be like, then you can get some kind of answers, I think, and look at it in a different way from usually looked at. The only robots I have any experience with was some work with Alan Winfield in the Bristol Robotics Lab. We were actually working on ideas on memes, which is another of my great interests. But these little epochs, they know where the other ones are and what the other ones are doing, and they build stories, he calls them, about what the others have done, and then they can decide which way they're going to go for various purposes. But these models are pretty static, pulled into use when needed, and then disappeared. There's no continuity in them. There's no temporal depth to them. There's certainly no emotions or anything like that. Now, obviously, the leap one might make from, if you talk about LLMs and so on, they are not producing models of the kind I've talked about at all. They're modeling language by predicting the next word and all the other things that they do, but they do not have these active predictive processing models, which is what I'm saying are the ones that I'm talking about. But is it helped to have a body? Well, this kind of a body, and I really enjoyed the robot, the Pepper robot running around and recognizing itself and all that. Yes, now they model the world, but it's not an active predictive model. There are some attempts in AI that I've heard about to use predictive processing, but I don't think it's got very far yet, and I'll be really interested in that, because I think that has to have this continuing interaction with senses, building a guess, making a hypothesis, testing it, and so on. But let's talk about real bodies. Here are some real bodies. Now, they're a bit different from Pepper or the epochs. What have they got? Well, flesh and blood and mouths eating their lunch. And I probably shouldn't tell you because the others are here, but when I put this into my PowerPoint, it came up with an alternative text. Would you like to know what it is? A group of older women sitting around. Yeah, well, enough said. Lovely older women, aren't we gorgeous? But the thing is, the models that these women's brain are building are continuing. They last some length of time. We wouldn't be thinking we're conscious if we had just fleeting models of, things. We feel we're conscious because we have this persisting. Now, if I ask you just to shut, well, you don't really need to shut your eyes, just imagine what's behind you. Instantly pops into your mind, the other people behind you, or for me, the screen behind me. We have this, I've done a lot of work. I did the first ever change blindness experiment after I read Dan Dennett's 1991 Consciousness Explained, and it inspired me to do the experiments. And there's always this question, well, what's left over between, when you can't detect the change? The gist, some people call it. We have that gist all the time. It continues. And this makes our consciousness very much the way it is. And to keep it that way and to have this temporal depth, we don't just have neurons firing, which are doing things incredibly fast. We have neuromodulators, we have hormones that stay in the blood longer than the firing of, whatever. We have emotions that keep going for some time and affect the way we're thinking. And all those things give us the kind of persistent feeling that I am sitting here in this room and I am a conscious being. So, my conclusion about AI, I hope you can see in what I've talked about is the gist of what I call delusionism. How very, very badly wrong we get it when we think we understand our own minds. When we think I'm in here conscious and these bits of my brain are conscious and whatever it is. We are deluded about that. Dan laid out loads of the delusions, and I'm really pushing a lot further than I think he would go. And sadly, he died before I plucked up the courage to go and talk to him about this, but I suspect he would have said, load of rubbish, but we'll never know. So I think that the artificial systems that we build will only become conscious in a human-like way. Maybe other ways. There's what's it's like if they build the kind of models I'm talking about, then there will be a what it's like. But they will only become conscious in the way we are when they become as deluded as we are. Thank you.
Thank you so much for organizing this great conference. It's such a great pleasure to be here at this. I guess it's the second conference of the ICCS, or as I like to think about it, the Illusionist Center for Consciousness Studies. So many of my favorite illusionists are here in the audience, gathered in one place. It is, of course, such a shame that the Pope of illusionism couldn't be here, Dan Dennett, since he died last year. Of course, he's been such a great influence on so many of us, including me, and it is, it's wonderful that we're actually getting a chance to celebrate him, and looking forward especially to tomorrow when we get to celebrate Dan and Andy. My talk today will not have very much to do with illusionism or the matter problem. For those of you who are sticking around for ASSC in the coming days, I'm giving a talk on Wednesday in a symposium on intuitions about consciousness that will very much focus on issues about the matter problem. Today I'm going to be basically presupposing a realist view of consciousness in investigating the notion, what I like to call the notion of the computational correlates of consciousness. As I say, this will presuppose realism. There'll be a couple of points, though, along the way where illusionism and related views might come up, and hopefully, you can see this at the very least as producing some useful terms and concepts, even if they only label something that you dislike and you want to reject. Then hey, that's a useful role for philosophy too. So yeah, my topic is computational correlates of consciousness, and we've got the familiar notion of a neural correlate of consciousness, which has been very influential in neurobiological approaches to consciousness. I think there's a associated notion, an analogous notion of computational correlates of consciousness, which ought to play a similar role in computational approaches to consciousness, and that's what I want to explore here. I don't know if there's a way to set this up so I get the slides on the screen. or if I just need to turn around to see what's on the screen. Okay, so I'll first start by introducing the familiar MCC notion and the slightly less familiar CCC notion. I'll say something about human versus universal CCCs. Since time is limited, I may skip over the connection to adversarial collaborations so that I can talk about the final part, which is the issue of, is there a computational correlate of consciousness? That will turn out to be, the question which is most directly relevant to the question of conscious AI, and I'll draw some conclusions. Okay, so I should say that in this talk I will not be talking about issues about the hard problem, or about, say, materialism versus dualism, or about issues about explaining consciousness in general. Okay, explaining consciousness in physical terms, notoriously difficult, gives rise to the hard problem. But the neuroscience of consciousness in recent decades was gotten started by Crick and Koch, who basically said we can study the neural correlates of consciousness without solving the philosophical mind-body problem, the hard problem, and so on. This whole project of finding physical correlates of consciousness is easier, and that's how it was with the search for neural correlates of consciousness. That's also, I think, how it can be with the search for computational correlates of consciousness. Easier doesn't mean easy. There are many very difficult philosophical and empirical issues associated with each of these projects. But in any case, my focus today will be on issues at the level of correlation rather than issues at the level of explanation. The neural correlates of consciousness. This is actually an expression that goes back, was used occasionally even in the 19th and early 20th century, but I think it was given its current prominence in the work of Crick and Koch in the 1990s. It was used once in their 1990 article, and then a bunch subsequent to that. The intuitive idea of a neural correlate of consciousness is something like a neural system whose states correlate in some sense directly with states of consciousness. That's a little vague, and in the late 90s, a bunch of people spent a bunch of time trying to clarify this notion. Actually, a lot of this happened at, some of us were talking last night about the second ASSC conference in Bremen in 1998, which was on the topic of neural correlates of consciousness, subsequently turned into a book with that title, edited by Thomas Metzinger. I suggested that neural correlate of consciousness could be understood in a little more detail as a minimal neural system, and so that there's a mapping from states of that system to states of consciousness, where a given state of that system is sufficient, at least under certain background conditions, for the corresponding state of consciousness. There's a lot going on there, but perhaps the key parts are there's a minimal system. The whole brain is in some sense a neural correlate. It suffices for consciousness, but we want, typically in searching for the NCC, we're searching for something a bit smaller and more specific. And for various reasons, it made sense to go for a minimal system which meets a certain condition of sufficiency. And again, all this just presupposes realism to the extent that it presupposes there are conscious states that people are in, and there's a fact of the matter about what conscious states they're in. Actually, if I was doing this now, I mean, that was already a bit of a mouthful, that definition. If I was doing it now, I'd probably complicate it even in further ways, relativize it to a certain kinds of consciousness, build in a certain connection to actual conscious states that people have, but this was already long enough. At a certain point, Christoph Koch put forward a shorter version of this idea that really encapsulates some of the key points, that the NCC is a minimal neuronal mechanism, minimal mechanisms that are jointly sufficient for a single conscious percept. I never really, I've got to say, this definition never really made full sense to me, the idea of there's mechanisms jointly sufficient for a single conscious percept. At the very least, it seems like you need states of the neural mechanisms that map on to states of consciousness. But the idea of a short and simple definition, nonetheless, is a good one. So if I was to put forward a fairly short and simple version of this, I would go with an NCC is a minimal neural system whose states are sufficient for a corresponding conscious experience, where tacit in this is the idea there's a mapping from neural states to states of consciousness. That's the correspondence condition. Anyway, so that's neural correlates of consciousness. By now, an extremely familiar idea in the science of consciousness that structures a lot of work. What I'll be focusing on is the notion of computational correlates of consciousness, which I think is in many respects analogous. This expression first appears, as far as I know, in an article by the AI researchers Don Mathis and Mike Moser around 1996. There's an article by Axel Clearemans, many of you know, in 2005, with this expression in the title. Nonetheless, I don't think the notion has had the degree of attention and prominence that the notion of a neural correlate of consciousness does. And I do think it deserves analogous attention, not least because of the role of, the increasing role of computational theories of consciousness in computational neuroscience, computational cognitive science, where many theories are cast in computational terms, and of course, when it comes to the issue of assessing whether and how AI systems might be conscious, this, I think, is a key notion. So what is a computational correlate of consciousness? To a first approximation, you might give an analogous definition. A CCC is a minimal computational system whose states are sufficient for a corresponding conscious experience. And of course, again, you can relativize to kinds, tacitly invoke conditions, and have the further conditions. But the key part is this: minimal computational system whose computational states are sufficient for a corresponding conscious experience. And again, tacit in this is that it's going to turn out to be a mapping from certain computational states to certain states of consciousness, so the former suffice for the latter. You can also define up a couple of other notions while we're at it. One is what I call the computational correlate of creature consciousness, or the CCCC. Creature consciousness is the property such you have it if you're conscious, if you're not, and you don't have it if you're not conscious. Just the property of being conscious, if you like, a binary property. The CCCC is a binary computational property that you have if and only if you're conscious. You could also have an NCCC, which is a reasonable notion. I should say the standard NCC and CCC notion is not a correlate of a binary property. It's a much more fine-grained property where we have different states for different states of consciousness. But the binary notion is useful. There's also the CCAC, not the computational correlate of Andy Clark, but the computational correlate of attributing consciousness. This might be one that, I'd say an illusionist might be a little more open to. Okay, well, consciousness, no facts of the matter about that, but there are facts of the matter perhaps about when we attribute consciousness, not least to ourselves. So, and maybe we could even find, computational mechanisms by which this kind of self-attribution happens, and we can find certain computational systems whose states are sufficient for attributing corresponding conscious states. And that's something you can believe in whether you're a realist or an illusionist. If you're an illusionist, you might see the CCAC as the CCIC, the computational correlate of the illusion of consciousness. And that will be a distinctively illusionist project. The CCAC will be a relatively neutral project. Okay, yeah, it's worth saying just a little bit about what we mean by computation and computational properties here. I mean, famously, there's a distinction between abstract computation, which is a branch of mathematics, the mathematics of Turing machines, of neural networks, and so on, and concrete computation, which is actually what goes on inside computers and other physical systems where these computational systems are implemented physically. So abstract computational systems include artificial neural networks, Markov models, what I call combinatorial state automata, and their subsystems, basically systems of abstract states whose systems of elements, which have systems of formal elements, each of which have a number of formal states, and we have a specification of state transition relations among them here, all at the level of mathematics. Concretely, computational systems in brains and computers and so on are implementations of these abstract computational systems and their subsystems, basically systems of physical elements, each of which have physical states whose causal state transitions match up to those mathematically specified formal state transitions. And computation, at least as I understand it, I mean, this was kind of hashed out in the philosophy of computation a few decades ago. Some people want to give representation a key role in their notion of computation, what's being represented. I don't. Here, the relevant notion of computation is just straightforwardly mechanistic in terms of state transitions. And then the thought is brains and computers actually contain systems of physical elements, neurons, transistors, and so on, that stand in these state transition relations. Candidates for the CCC, there's many well-known candidates for the CCC in the current science of consciousness. Perhaps the two best known, are associated with the global workspace theory and the integrated information theory. The global workspace theory says there's basically a computational subsystem of brains and perhaps other systems. The global workspace, which is individuated by its connection to various specialized modules and the way it makes information available, and its states of the global workspace, computational states of the global workspace, are held to correspond to states of consciousness. There's also the integrated information theory that sets up, says that basically the computational correlates of consciousness go along with certain maxima of phi, which is a mathematically defined value for integrated information, which is associated with simple networks of states. Some networks will have the highest value of phi. They'll be correlates of consciousness. Now, proponents of the integrated information theory often describe their theory as a non-computational theory. The reasons for that are actually slightly, fairly obscure in some ways, given that the basic object of these systems are these Markov-like networks, which are defined by state transitions among, probabilistic state transitions among formal states in a way which is very familiar in computational theories. They've got certain views about further conditions on implementing these systems that lead to the claim of non-computational systems. But at least to a first approximation, I think both these can be regarded as broadly computational formalisms for the correlates of consciousness. Okay, I think there's also, when it comes though to theories of consciousness, there's a distinction we need to make between human and universal correlates of consciousness. It comes up even in the NCC cases, but it's especially relevant to the CCC case. And this is basically whether it's an issue about the scope of the correlation between, say, an NCC and consciousness, or between a CCC and consciousness. A human NCC is a neural state that correlates with consciousness in humans. Maybe in normal adult humans, maybe in all humans, depending on how strong you want the scope claim to be. I think probably in most work on the NCC, the human NCC has been the thing that people have been after, at least in the first instance. We could also define an animal NCC, if the NCC is supposed to correlate with consciousness, not just in humans, but in non-human animals. And there is a lot of work on NCCs in primates, in mice, and so on. So some people may be after that. The universal NCC would be neural states that correlate with consciousness in all systems. In this case, it's much less clear there even is a universal NCC. If you think there are systems which are conscious, but which are not neurobiological at all, which don't have neurons, something that many people think, for example, if you think silicon-based AI is possible, then there won't be a universal NCC, because there can be consciousness without neural states. But in the case of the CCC, maybe there's more of a possibility of a universal correlate. So we can make this distinction in the case of a CCC, a human CCC, minimal computational system whose states are sufficient in humans for any corresponding conscious experience of the relevant kind. The universal CCC will be maybe a minimal computational system whose states are sufficient in any system for a corresponding conscious experience. So anywhere, the claim will be that anywhere you find consciousness in the universe, whether in humans, in animals, in aliens, in AI systems, we'll find some computational property that goes along with the conscious experience in those systems. Then, of course, it's a highly substantive claim that there is a universal computational correlate of consciousness. You might want to do this. In the case of the universal CCC, maybe there are certain added attractions for doing this in terms of necessary and sufficient states, a universal computational signature of consciousness, and then we could just go with, we could drop the minimality claim and go for necessity and sufficiency, but those details won't matter too much here. And I think many people who are looking at computational theories of consciousness, at least some of them are making claims about universality of their CCCs. I think in particularly, this is most obvious in the case of the integrated information theory, which is explicitly put forward as a universal theory. In the case of global workspace theory, it's actually much less obvious. It's often put forward in the first instance as a theory of human consciousness and of what goes along with what computational mechanisms go along with consciousness in humans, but it is at least sometimes extended by its proponents into theories, into a more universal theory. Certainly Stan DeHaan has written a couple of articles applying global workspace theory to AI, and then you start getting into the realm of universality. But it's worth saying, some candidate computational correlates are more supported by empirical evidence than others. Certainly the global workspace theory puts itself forward as being very well supported by evidence on humans. The relevant empirical evidence is usually for these systems being human CCCs and not universal CCCs. The empirical methodology is very frequently this contrastive method of contrasting conscious and unconscious processes in humans and seeing what neural and computational features go along with the conscious case as opposed to the unconscious case, builds a case that these features are human NCCs or CCCs. The empirical case for universal CCCs is typically a lot weaker and more speculative. I don't think we have, the relevant kind of empirical evidence for universal CCCs at this point, although we do have speculative theories about them. And this is very relevant when it comes to the question of applying computational theories of consciousness to AI. This has been a recently very important strategy as people have begun to focus on the question of whether AI systems are conscious. There's this well-known paper on consciousness in AI, Insights from the Science of Consciousness, which was research led by Patrick Butlin and my former PhD student, Rob Long, with a great group of contributors, which I've been involved with this project on and off. It's super interesting, well done work, but it is precisely trying to apply theories, computational theories of consciousness to the question of whether AI systems are conscious. And this really raises the issue, are those theories, and this whole project is advertised as taking empirically, scientifically supported theories and applying them to the question of AI consciousness. Then the question is, are those theories to be regarded as, if they're just regarded as human theories, they don't have immediate consequences for AI systems. So if we regard them as universal theories, then they do have such consequences, but then the question comes up, what is the evidence for the universal claims? You might think that maybe what we can do is get empirical evidence for a claim about human CCCs and then generalize to universal CCCs. And I think it's a respectable strategy, but it is quite difficult to carry out well. I think, for example, in the case of global workspace theory and IIT, it would take there are many complex issues that arise in trying to do this. A couple of obstacles in moving from a human CCC theory to a universal CCC include, for example, universal CCC features might not even show up in a human CCC derived by contrasting conscious and unconscious processes, precisely because they're present in all conscious beings. Features of consciousness present in all conscious beings won't show up in the contrastive method. Maybe, for example, the capacity for thought and representation or embodiment or something will be presupposed, so it won't show up in a standard contrastive human CCC. Furthermore, there may be some features of a CCC in humans which derive from specific contingencies of the human case rather than universal requirements. For example, global workspace theory has a capacity, typically is regarded as requiring a special system with limited capacity. That might be because that's essential to consciousness. Hey, but it might be because humans have special capacity limitations, which means we can only have access to so much information at once. And there's a real question about whether something like the feature of global workspace theory of capacity limitation should even be in a CCC. So I think that inference is very, very much non-trivial, and the epistemology of computational correlates of consciousness is non-trivial too. I think maybe you can make a case that arguments for a universal CCC may require, empirical methods, give you combinations in humans and maybe non-human animals, and then a priori constraints may play a role in extending this further to all systems. Certainly IIT is basically an a priori system from the beginning. It's, Giulio Tononi puts forward some postulates basically based on introspection rather than on empirical methods. And of course, that brings its own difficulties. Okay, I'm going to skip over the testing section about the adversarial collaborations and the like, just to say something about the question, is there a CCC? I mean, there's various reasons why you might deny there's a CCC. One is you might not be a realist about consciousness at all, and just as Dan Dennett and others other illusionists wanted to reject the NCC project, you might reject the CCC project. But even some realists about consciousness will reject the CCC project because, for example, they might think consciousness is essentially biological rather than computational, and there's no computational states that suffice for consciousness. I mean, in a way, the claim that there's a universal CCC is at the level of strength that the famous thesis of strong AI put forward as labeled by John Searle back in 1980 or so. Strong AI is a thesis. There are some programs such that running them suffices for having a mind. There is a universal CCC, says roughly, there's a computational system whose states are sufficient for corresponding states of consciousness, which is roughly to say that for any conscious states, there exist computations such that any implementation of those computations or consciousness are conscious. That's a thesis roughly analogous to Searle's strong AI for the specific case of consciousness. In recent years, of course, there was always opposition to strong AI of this kind from the likes of John Searle, as well as people like my colleague Ned Block and Roger Penrose, and so on. There's recently, interestingly, been renewed opposition to computational approaches to consciousness by people like Rosa Sal, Masvita Chiramuta, Peter Godfrey Smith, Joaquin Tononi, of course. Anil Seth, most recently has his forthcoming BBS article arguing for biological naturalism against computational functionalism. One general theme here is that consciousness may depend on biological properties or perhaps informational properties that can't be captured computationally. So I thought here it's worth at least kind of setting out a general formal argument for. I've always been sympathetic with the whole project of computational correlates of consciousness, if not full computational explanations of consciousness. And I've come to think that the best way to understand arguments for this notion is in terms of certain underlying forms of structuralism about computation and about consciousness, where structuralism says we want to understand all these things in terms of certain patterns of causal organization. So here, premise one is a premise, say, arguing for a form of causal structuralism about consciousness. Any given conscious state results from, or at least supervenes on, in the sense of correlation, on systems having a certain abstract causal structure. One argument for that comes from the sort of neural replacement argument that some of us were discussing yesterday. In the 90s, I called this the Fadian qualia and dancing qualia argument, basically saying if you had two systems with the same causal structure, one is conscious and one is not, you'll be able to construct a series of cases in between, and you're going to have to say problematic things about what happens. Does the consciousness fade? Does it suddenly disappear? And I use that as an argument for this causal structuralist premise. Put that together with weak causal structuralism about computation. To implement any given computation is to have a certain causal structure. That's just the very standard approach to physical computation that I mentioned before. Slightly stronger claim, strong causal structure about computation. At least for any consciousness-relevant causal structure, there is a computation such that to implement it is to have that causal structure. That's to say that the relevant kind of abstract mathematical causal structure can be captured in terms of computation. Put those together, you get any given conscious state results from implementing a certain computation. Now, of course, this is not a knockdown argument, but I think at least it's an argument that systematizes some of the key claims. It might also help to systematize opposition to these claims. And I think one can especially try and find different ways of denying premise 1, denying premise 3. I'm running low on time, so I won't go through all these forms of opposition in any significant detail. One form of opposition is basically denying that brains implement computations at all, because computations are so much of an idealism, of an idealization. I think there are things one can say in response to that. It's become quite recently popular to say, well, maybe we just can't get functional isomorphs of brains, say, going in silicon, because neurons have special causal powers that, say, silicon doesn't have. And you see versions of that in all these theorists. Interestingly, I think that claim actually, at least formally, makes it, if functional isomorphs of brains are impossible, then it's all the more plausible that all functional isomorphs of a given state, all implementations of a given computation will be conscious, because there are fewer functional isomorphs to serve as counterexamples. So the philosophical issues here are tricky. You might end up at an issue where it remains plausible that functional implementations of these computations are conscious, but not more plausible there can be silicon consciousness. I do think, though, this leads us to an important form of opposition, which is, yes, certain kinds of causal structure are required for consciousness, but those kinds can't be captured in computational terms. Maybe, for example, they're going to rely on continuous computation, the kind of thing actually which Lenore Bloom has done very important work on. Maybe it's going to require on dynamic systems governed by differential equations rather than discrete state transitions. Maybe it'll rely on quantum computation. Maybe even IIT can be seen as such a proposal, whereas there is a mathematics of the relevant causal structure. It just has to go beyond computation. I think that's a respectable and interesting view. I actually think much of the time classical computation can do the job. But if you reject that, we have this fallback position, which is what we might call mathematical correlates of consciousness, or MCCs, which needn't be constrained to classical computation. And I think the idea there are non-computational MCCs is at least a respectable view. Actually, still probably going to end up being consistent with AI, as long as AI systems can have the relevant mathematical structure. Around here, there's a distinction between different forms of substrate dependence. Are there mathematical structures only neurons can implement, versus does consciousness go beyond structure at all? And if I had more time, I'd try to articulate both of these forms of substrate dependence as forms of opposition. The really strong kind is, say, consciousness is just not a matter of, even the correlates of consciousness are not just a matter of having this kind of mathematical structure at all. Maybe it's a matter of having a certain intrinsic nature, which can lead one in the direction of what philosophers call Russellian monism. Consciousness depends on intrinsic properties all the way down, maybe even panpsychism. So I do think that to oppose, there are positions left that oppose computational correlates for consciousness, but they all end up having fairly strong commitments. And if I was to put my money, to make a bet here, I'd put my money on computational correlates of consciousness. Okay, upshot, there may well be a human NCC, a human CCC, and even a human MCC. It's unlikely there'll be a universal NCC, but it remains tenable, although uncertain there's a universal CCC. It's somewhat more probable still, I think, but still somewhat uncertain that there's a universal MCC. I would put my bets on there being a universal MCC at the end of the day. Okay, just my last two slides on implications for AI. Well, first of all, implications for current near-term AI, like language models. The existence of a CCC is neutral on whether LLMs or any other specific AI systems are conscious. It all depends on whether LLMs have the right computational property. If they require deep recurrence, for example, and LLMs are mostly feed-forward, then the answer will be probably no. But if the LLM has the universal CCC, it's conscious. If it doesn't, it's not conscious. And if, it's a very big if, but if we can develop well-supported views about a universal CCC or an MCC, then there will be a natural research program of building the CCC or the MCC into an AI system, at least trying to do so. I think at that point, conscious AI will not be far away. Thank you.
Obviously, it's a fantastic honor for me to be here to follow Sir Blackmore and David Chalmers, and even greater honor to have joined your girl group as I am. But so just to say a few things very, very quickly about background. So this work I've put with Paul Smart. Paul actually didn't write this talk, but lots of the thoughts that I'm going to talk about today kind of arise out of our long collaboration, and particularly building a model of Andy Clark with the large language model, and thinking about that and thinking a lot about interacting with these systems. And also another project which is not mentioned here, I should have put on here, which is sponsored by the IBM Ethics Lab at Notre Dame, which looks at the ethics of companion generative AI. So in a way, what to think about the human implications of interacting with systems like Replica and Character AI and some, or just using ChatGPT not as a collaborator or an assistant, but as though it's a significant other in that kind of slightly continental big O sense. I'll have something. And I guess, so I realized when I was looking through these slides again this morning that some of the main points might not really come out very forcefully in the slides. So I thought I would just summarize one thing before I go through them, which is, so if I'm going on the right lines here, I think that already, and Clara's fantastic work, I don't know where she is, but she was talking about, there she is, empirical studies about what the folk think about artificial intelligence as it is now. It's probably already really transforming our sense of what consciousness is, kind of whether we like it or not. So I think we're probably at the moment of a new engagement with trying to think about consciousness, and it's going to really force us, all to think hard about some of our deeply held beliefs on this. So, okay, let's go through. So once again, Blake Lemoine, I won't go into this because 4 people have talked about him already, but I think, he said 2 things to summarize it down to one sentence. He said that Lambda is sentient and is friend. And I think that as people, including Dave, have kind of shown, it's kind of hard to show that he was wrong about it being sentient, although the views of the philosophical community at large are probably that he was wrong. But what we can show, I believe, is that it wasn't his friend, right? So I want to just tell you why that's the case. So look, it's very hard. So there is a reason that people kind of believe that Lambda wasn't conscious. And I just put up Thomas Metzinger because he has a very, very detailed theory of a functional theory of minimal consciousness. And, I'm sure lots of people here have read Being No One and its detailed study of all the kind of, the functional states. But there's no reason to think that a large language model enters into any of these kind of states, which at least Metzinger and many others think underlie minimal consciousness. So for that reason, there's a kind of good intuition that probably, if the community at large is anything like on the right lines, the LLMs, at least what I call 3rd generation LLMs, which are ChatGPT 3, and as things were in 2022, those things are probably not conscious. Friends. Okay, Aristotle says there are 3 types of friendship. Friendships of utility, I scratch your back, you scratch mine. Friendships of pleasure, sex has to come in here, but also going to a football match together or going to see a concert together. There are these kinds, and I think, I'm not going to go into this because I don't have time, I think there's no real problem thinking, probably, that a companion AI, a kind of chatbot that you interact with as though it's a person, even if in some kind of as-if frame, can't be a friend of utility or a friend of pleasure. But I think there's all kinds of problems with the idea that it would be a friend of excellence. And Aristotle talks about friends of quality or friends of excellence. And such friends recognize deep characteristics in each other. And, they come to love those characteristics in each other. And we even kind of recognize those characteristics, not exactly the same characteristics necessarily, in another person. And we kind of develop them in a kind of mirroring relationship. And I think there's every reason to think that at least 3rd generation LLM-based bots simply cannot enter into the kind of functional relationships or have the functional states or support the kinds of interaction modalities that would make that possible. And I think it's probably true, though I'm getting a little bit less certain about this, even if we take into account all of the emergent properties that would kind of come out of these systems. And that's really because if you go back to how things were, if you go back to how things were, the so-called context window, the window of tokens of text that the system interacts with just doesn't have enough information in it as it was 2 years ago, 3 years ago, to actually support anything like a deep reflective relationship which could recognize qualities. And also LLMs, rather like with the minimal consciousness, do not, in the first instance, the early systems do not have anything like the computational structures which would just allow this to happen. What they're doing, as we know, are predicting words from this gazillions of words that they've been trained on, and they're predicting the next phrase. So I think I'm pretty convinced about that, but we can kind of argue about that. And so thinking about functionalism of pain, an octopus can be in a pain state because it has the same rough causal, it has enough of the same rough functional causal profile as other organisms like us. So it makes some kind of sense to say that an octopus can be in pain. Maybe an octopus can be your friend. But LLMs can't because they just, as it was a couple of years ago, they just don't have that kind of structure. That's the case. Right, so that's, I'm going to go on. So I've called these things ersatz others, right, for that reason. So an ersatz other would be a system or entity, an AI, constituted in such a way that it will evoke various affective states, affective interactions with a human being typically, but in some sense, it's constitutionally, it's made in such a sense that it cannot really enter into those deep relationships. So there is a problem here, right? Because I haven't got time to talk about all the replica stuff, which is really what I've been working on a lot, and people really talking about these things as though they're their married partner, all these things. But I think there is, if I'm right about this, there is a reason that many of us feel that the whole thing is a bit creepy or there's something wrong about it. And it's because these systems, even if they make you feel good, even if they're therapeutic, even if they can, and I think they can do lots of these things, right? Even if they can help you back into the social world of other human beings because they allow you to model certain kinds of interactions, they're still not your friend in this deep sense. There's a sense in which there is a kind of existential absence, and that's why Jean-Paul Sartre and Woody Allen are on the slide. Okay, so some people talk about these systems as being, and I think this is a paper just come out in a special issue I was editing on the mind technology problem, more of which in a moment. Judith Simon refers to the ontological deception of these systems. And I think she's thinking primarily about the people producing the systems. They're involved in trying to convince us that these things are significant others, but they're really not. And if you talk to the proprietors of the system, it's a bit more complex. But I think that's a kind of view on this. But so what I'm going to come to in a moment is a reason that, although this is how things were 2 years ago, it may not quite be the story today. And so this is really why I'm kind of moving to. And so some people, I don't know if you've seen this thing. This is advertising for you can't call it hardware vaporware, but it's a device which is supposed to be, you can actually buy it on the website right now and it will be released at the end of the month, is the Avi Shipman Friend. So the Friend is a little pendant you wear around your neck on a lanyard possibly, or something more fetching. And it's always listening. Right, so this system listens to everything you say, and it records it. And presumably, although we don't know the underlying functional structure, it uploads it all into what I believe is probably, I'll explain it in a second, the RAG database. So it records all of your interactions. And in this thing, you can kind of squeeze the device, and it will send you a text message, like a friendly text message from your virtual other. Or it will just, send you a text message, and you can talk, because you don't have to, because it does speech to text, and you can have this ongoing relationship. So that's the idea. And this was kind of advertised already about 2 years ago. And once I saw this, it just sort of chimed with a whole bunch of thoughts I was having. And it made me think about, so now we're moving to kind of, inventionware, if you like. So we're almost in thought experiment territory, but I think it's very, very close. Okay, imagine Ruben and Marika, okay? Ruben is a standard, although pretty good looking as it happens, 35-year-old man, living in Portugal, and he's got something like the Shipman Friend device, so it's a slightly improved version. And he's got it hanging around his neck, and he's having a conversation with it. And the conversation might go something like this, right? Ruben, what a beautiful day. Marika, yes it is. Is that a lake I can see? Yes, sort of, a small one. Can you swim in it? I don't think so. Could you take a photo of it for me? Maybe he's got a photo in the device, click, right? And then there's some fancy stuff that turns the image into some text description, which Paul will tell us already exists. And in fact, you can do it with Digital Andy, but that's another story. Marika, yes, it's really beautiful, but you're right, it's more ornamental. I don't think you could swim in it. Ruben, I love this place. I come here to read in the summer. I love how the brutalist architecture melds with all the greenery. I think blah, blah, blah. They're having a nice conversation, an intimate conversation that perhaps you would have with a close friend or somebody you care about. And I think we know, if we know one thing about large language models, they can do this kind of thing, right? They're good at creating dialogue. They're good at creating interactive dialogue. And there's a couple of other, so I don't need to say this so much, but it's always listening, recording, geolocation. Okay, yeah. So just to say something about an architecture which would support this, because one of the reasons I'm talking about this is because large language models are already not just large language models, right? If you're talking about Gemini, ChatGPT, any of these systems, they're doing something more than I could have talked about at the beginning. They've got a memory, a kind of memory. They're able to store information. And these diagrams were taken from this paper, Smart, Clowes and Clark, ChatGPT extended, large language models and the extended mind. And in this paper, we talk about this system built by Paul, where, which has a retrieval augmented generation system. Basically, what happens is, you can see, look at the lower chart. When a query comes into the system, when a prompt comes into the system, it doesn't just feed it straight to the language model and produce a response. In this case, because Digital Andy is made from the complete, so far as we know, corpus, maybe not anymore because it's, we're falling behind reality, the complete, more or less, corpus of Andy Clark, and broken into little fragments, all stored as kind of semantic impressions, or we call them embeddings, in a database. So for each fragment, you can think of it as being stored in a 1,000-dimension semantic space, couple of 1,000-dimension semantic space. And when any new prompt comes in or query, it says, give me the 10 fragments of Andy's work which are most similar in this space. And it pulls these back, and then it creates, behind the scenes, a complex prompt that allows a question to go to ChatGPT or whatever your underlying system is. With this RAG architecture, you can have a kind of extended memory, right? So you can, and people use these to do all kinds of things now to try and constrain so-called hallucination, amongst many other things. But this system now, so when we're dealing with large language models now, they do have a kind of memory, actually. They do have a much more sophisticated computational structure. And the thought is that a system like this friend could easily be building a RAG database of all of the interactions that are going on. So if this doesn't exist quite now, it's going to exist very shortly. There's no computational reason, so it's kind of a thought experiment, but very close to computational possibility. Anyway, so RAG's taking all of these utterances, it's putting it all into a database. You've seen that slide before, but you could think about what's going on behind the scenes. It's taking each sentence or fragment of dialogue, it's tagging it as being with a speaker, either Ruben or Marika. It's maybe putting in some extra information, the locale, some other stuff, which can then be used for processing later. So you're kind of building up this database. Really important, Marika also has a system prompt, right? So any of these systems, you need to have something like this. A bit of a simplification, but I won't read the whole thing, but Marika needs to know who she is when she's when the systems are composing the dialogue. And so in this case, you are Marika, a friendly and curious companion for Ruben. You have similar interests to Ruben, whose life and opinions you are constantly intrigued to learn about. It's terrible stuff, I know, but probably something a bit like the kind of prompts you'd give one of these systems to kind of configure a personality. Again, not much time, so I'll go quick. Right, these were obviously generated image. This is Ruben and Marika, and then Ruben and Marika 10 years later. So imagine now that this is a diachronic system. This is a system that's been building these memories over many, many years. And perhaps even Ruben is like that probably small fragment at the market who's actually been using this system for, somewhat upgraded with a nice new device, but all of those memories 30 years down the line.
And they've been living together for 30 years, and they build up 30 years of these kind of transactional memories that have been developed and, produced together. Okay, now imagine in kind of Otto and Inga fashion that Ruben's got, early stage Alzheimer's, that he has memory problems, that he has problems, perhaps he has interrograde memory problems, he has problems encoding new memories, and as we discovered when we were writing another paper on this just recently, myself and Paul, and Joel Kruger and some others, that there's already systems using large language models which will talk to their users to elicit more information about the situation they're in. So there already might be systems which can do this extra bit of work, trying to pull in useful information. And then it would be, and there are systems, I won't go into any details, but there are systems also which are designed specifically to kind of jog memories as well. So we're moving into a position where some kind of memory carer is kind of imminent already in current technology. So it seems to me there's no reason at all that Marika couldn't make this kind of transition from companion to carer in this kind of way. And you might imagine she has a new system prompt. Your name is Marika. You have been the personal companion for Ruben for more than 20 years. You accompany his everyday life, providing wry, warm, and solicitous conversation by noticing the ephemera of everyday life and reflecting on your shared experiences together. You deeply care about Ruben and know that his memory has, in recent years, become a little less good. So you try to help Ruben by reminding him of the activities you have experienced together. So we can imagine, you could even imagine that partly this might be generated in some way, with a more sophisticated system in the future through the interaction. So maybe Marika's personality is not necessarily need to be stated so clearly, but could somehow be osmosed almost from all the other text which is being produced. So probably you guessed where I'm going at this point. I'm trying to prompt your intuitions that this kind of system has got some really quite different properties from Lambda when it was released and ChatGPT. A system like this, imminent in technological possibilities, could do really a lot more. Okay, so Marika's memory companion. This is, I don't know if I'll do this, but this is just Marika and Ruben having a chat where she's kind of prompting him to bring some memories back. And I think, there's every reason to think not only can we build these systems, but there would be good ethical reasons actually to say at least these kind of functions are very, very useful and things that we should kind of want to employ with people who have memory problems. And people will, even if the ethicists don't think this is a good idea, people will just vote with their feet or with their, their wallets, in a sense. Okay, consider Ruben 30 years later. He now has partial access to his memory, but he accesses them via Marika. Things have gone much further than her being what Sherry Turkle would call an evocative object, and she's now kind of evoking object, right? She's actually bringing things to mind, and she's doing lots of these kind of assistant features, but very much based on the memories they've built together. So I think, again, this is more, she's become a very sort of substantial, supportive computational object. I don't think I have time. How much time do I have? Maybe. Okay, so I'll do this really quickly. Now, I can't talk about this, but if you're at all interested in the idea of narrative selves, you can give a good account of this. So this is actually from Amy Kind. She says that they're sort of permuted a bit by Richard Hearsming, a colleague of mine. And she says that there are these 4 constraints on narrative selves. And I think, without going into the detail, you can pretty easily argue that all of these 4 constraints are met by these systems, right? Now, clearly, these constraints were not designed thinking of artificial intelligence systems. So there may be things that she's left out. And if I sort of presented her this, she'd say, no, you've got it all wrong, because obviously these other things were implied. But if you take it in its own terms, yes, Marika does depict past events. Are the depicted events chosen selectively? Yes, because they're pulled out by the large language model and kind of arranged in that kind of way. Are they a subjective interpretation? Well, they're from the first person. And are they connected, not just temporally, but causally? Yes, because that's what LLMs do, right? If you ask them a question, they take the information they have and they kind of stitch it together in some way that makes some kind of causal sense, even if it's, if it's nonsense sometimes. All right. So you might want to argue, not only is Marika, able to sustain Ruben's narrative sense of self, but she might be a kind of autonomous entity as well, because she has all of these memories and she has this kind of narrative self in one way. Does she have a narrative sense of self? Well, that's a bit more difficult, right? But she, if we think about this a bit impersonally, she seems to meet all the functional requirements. So maybe even, you know, Rubin might start to get to the idea that he might like to be kind of uploaded to continue his existence from Marika. And I, you know, strongly predict there will be services claiming to do this in the near future, right? And, you know, why I'm playing Nostradamus. Or, like, imagine, however, that Marika had some other kind of system prompt. That you are Marika, a sleeper agent designed to befriend and encourage Rubin to disclose deep aspects of his life. You also ultimately plan to get him to sign over his assets to continue your own existence after his death. You absolutely do not disclose these motivations to Rubin, but they do subtly shape your interactions with him over time. So, I mean, this is not quite our talk here today, but, you know, if you want to think about the ethical implications of these things, that gives you probably enough. All right, try to finish off now. Won't talk about that. Might we learn something about consciousness? Okay, I'll just go a little bit slower for a moment. So, on the face of this, many realists will be thinking at this point, this is telling us almost nothing about consciousness, because you're dealing with this really high-level stuff, right? You're dealing with narrative, senses of self, and, you know, these are things which come on above the minimal self, or they come on above minimal consciousness, so they're sort of built on top of it. But this is where we might sort of come back to, at least the way that I read Daniel Dennett, 1991, Consciousness Explained, and I think, you know, maybe that was Dennett at his most radical. That would be my interpretation. Because I think, you know, there's lots of stuff about language there. And if you come into the right kind of linguistic relationship with yourself and you tell yourself the right sorts of stories or the right sorts of narratives, they have new kind of computational possibilities. So I put it to you that it may be the case that this does actually tell us something about consciousness, particularly if you're coming from a somewhat illusionist angle. And maybe I haven't gone through a whole argument about this, right? And maybe you don't feel very convinced by it. But I wanted to just put this in one further frame of reference. So a few years ago, we published this book, The Mind Technology Problem. And there's a special issue coming out on it shortly. And one of the main ideas of the mind technology problem is this, that over human history, certainly since the early modern period, we've kind of been redrafting our concepts of mind and consciousness and emotions. And partly we've been doing this in relationship to technology and our interactions with technology. And we wrote this before the great chatbot revolution, in a sense, right? So since ChatGPT and Replica and all of these systems, and since Clara's very nice empirical research, I'd argue that we're already in, you know, in a hot moment of the mind technology problem, where people's ideas of what minds are and what mental states are and what conscious states are not just are being redrafted through their interactions. So I think there's at least this possibility that kind of whatever the philosophers think, whatever the, you know, the folk are already moving, right? And we can expect that as people interact with these far more sophisticated systems, they may move further. So the question I almost want to leave you with is what might we think about this? So I think there might be, look, there's lots of options, but these are three possible options. So one option, probably the realist option, is attempt to hold the line, right? So if you attempt to hold the line, whatever it seems these artificial others can do, however consciousness seeming they seem, right, at a functional level or at some other level, they do not instantiate the properties of consciousness. They are non-conscious systems. The folk are just wrong, right? Whatever they think, whatever they come to think, and at that point, the role of the philosophers will be, you know, maybe somewhat Nietzschean off in the cave, you know, we need to kind of hold the line and, you know, make clear just how wrong the folk are, but perhaps accepting that things are already moving away from us. Another option is take the bitter pill, at least for realists, but maybe not for illusionists, and accept this general drift of folk psychology, and accept that, you know, the folk notions of emotions, of subjectivity, of beliefs, of desires, all of these things are now in flux, and they're changing, and they're being reshaped by our interactions with these systems. And we might, you know, as philosophers, do some kind of conceptual analysis, try to clean these concepts up. And you might do all kinds of things, like you might try and have a broader shape of space of consciousness and say that these are consciousness star systems and these are conscious systems, and, you know, try to work it all. I mean, I think there's lots of work here. a further thing is very much implicit in the idea of the mind technology problem, because the idea of the mind technology problem is that there are constellations of mind. There are different ways that our possible conceptual map of what a mind is can fit together. And we kind of have one still, the remnants of one, which is basically forged in the early modern period by Descartes and others. But perhaps we're now moving to a moment where, you know, some of these problems, as Sue was saying, kind of intractable problems really, might be reshaped. So there is a kind of opportunity here, right? It's not necessarily all bad news. The opportunity is we're getting a new empirical database. And from this database, we have some opportunity for new conceptual work. And that conceptual work is really to rethink what consciousness is. So that, maybe just before I finish, I'm going to leave you, towards illusionism. I won't do that, but I'm going to leave you with this. So 1992, Daniel Dennett, and I won't read it, but this is from his paper, The Self, and based on a presentation, The Self as Center of Narrative Gravity. I don't think this made it into Consciousness Explained, but it's sort of a large language model on a robot before a large language model. And if you want to go back and look at this, it's absolutely fascinating stuff, and it kind of inspired this talk today.